Howdy, today I'm going to talk about acid rain. So you need to be able to describe and write equations for the formation of acid rain and describe the environmental effects of acid rain, including action on metals and carbonates and on mobilization of toxic cations. So normal rain is typically a little bit acidic because of carbon dioxide in the atmosphere. So the carbon dioxide dissolves in the water in the atmosphere, producing carbonic acid. Carbonic acid can then ionize to produce hydronium ions and carbonate ions. So the increase in concentration of hydronium ions reduces the pH and makes it slightly acidic. But this isn't what we're really talking about when we're talking about acid rain. So natural rain is normally between 6.5 and 5.6 pH, and that's because of that carbonic acid. Below 5.6, you can't really add any more carbon dioxide into the water, it just doesn't go in, it's already saturated. So when we're talking about acid rain, we're talking about rain with a pH of less than 5.6. And that's produced mainly from the result of human activities releasing oxides of nitrogen and sulfur into the atmosphere. So we'll start by talking about nitrogen oxides. So they're produced wherever you have really high temperatures. You need really high temperature to break the triple bond between nitrogen atoms. So between the two nitrogen atoms is a very strong triple covalent bond. You need to break that in order to get the nitrogen to react with anything. So in a combustion engine, you have the nitrogen reacting with oxygen to produce nitric oxide, which is NO. That nitric oxide then further reacts with oxygen to produce nitrogen dioxide. Nitrogen dioxide is an acidic oxide, and it reacts with water in the atmosphere to produce nitric acid and nitrous acid. So here we have nitrogen dioxide reacting with water, producing nitric and nitrous acid. Because we've got these, a weak acid and a strong acid dissolved in the rainwater, that lowers the pH and makes it acidic. It's very important if you're using these equations, you should probably show the ionization and the production of hydronium ions. Oxides of sulfur are produced whenever you burn anything that contains sulfur in oxygen-rich environments. Often coal is a good example. Coal contains a lot of sulfur. So when you heat up the sulfur, it reacts with oxygen to produce sulfur dioxide. And again, sulfur dioxide reacts in the atmosphere with oxygen to produce sulfur trioxide. Both of those, sulfur dioxide and sulfur trioxide, will dissolve in atmospheric water and produce weak sulfurous acid for sulfur dioxide and strong sulfuric acid for sulfur trioxide. So you get these weak and strong acids dissolved in rainwater, and that again reduces the pH. Again, if you're going to use these equations, it's a good idea to show that it's acid by showing the ionization and producing of the hydronium ions. So you can get acid rain occurring naturally, usually after volcanoes go off. You get a lot of sulfur going into the atmosphere, so you get sulfur dioxide being produced and the sulfur trioxide. You can also get it from aerobic decay of dead plants and animals. When they ionize in water, you get the hydronium ion being produced, and that reduces the pH, like I said. The main places that we notice acid rain are North America and Europe, not so much in Australia, also in Asia too. You need to also be able to talk about the effects of acid rain. So plants are damaged in a few ways. The leaves, if you spray acid on leaves, they get damaged, and that reduces the ability of the plant to do photosynthesis. Damaging the leaves also damages the coating on the leaves, and that leads to ions being leached from the leaves, again reducing the ability of the plant to do photosynthesis. So you have essential metal ions, so things the plant need, like magnesium and potassium, and toxic metal ions. They can be mobilized off of the clay surfaces, and I'll show you a picture of this in a second. If you remove essential ions and wash them away and release toxic ions, then that can cause damage to plants. So we'll talk about leaching. So in leaching, you have clays in the soil that have a surface negative charge, and you get positive cations attached to those negative surfaces. And they can be good things like potassium or sodium, which are required in amounts in plants, or they can be things that are toxic like aluminium and cadmium. So they stick to the surface of the clay. When you wash in an acid, you can get replacement of those cations with hydrogen ions. So they can stick to the surface of the clay, and that means that the cations that you have there, they go into the soil water. And this could be a good thing if it's something like potassium, because then the plant can absorb that potassium. But it can also be a bad thing if you're mobilizing things like aluminium, which is very toxic. So aluminium isn't good. If you have it in the soil water, the plants can absorb the aluminium, and that can cause damage to the plants. So why is aluminium toxic? It disturbs the defense mechanism that plants use to fight disease. They can damage bacteria that decompose vegetation and reduce the ability of the bacteria to recycle nutrients. In fish, it can stop the ability of the gills to work, leading to suffocation of the fish. The ions can be washed into lakes and streams, and that can make them toxic with high levels of aluminium. And also, acid washing into lakes and streams can be bad because it'll kill off the fish as well. So it'll kill the eggs and the fry, which means you don't have fish there. So there are lakes in some countries that don't have any living things in them because of the amount of acid that's been washed into them due to acid rain. Acid rain also has effects on the built environment. So limestone and marble are made out of calcium or magnesium carbonate. And you shove any acid near there, you get this reaction here. So you've got a metal carbonate with an acid, so you get a salt, carbon dioxide, and water being produced. And you can see this very dramatically in this picture here. So we have a picture of a statue over here, so from 1908, and here from 1969, and you can see all the features have been washed away essentially. And that's because the acid rain has dissolved away the features. The calcium sulfate that's produced can dissolve and find its way into cracks inside buildings. When the water evaporates away, that means you're left with the deposit that expands in size, and that leads to cracks and fracturing. So you can see on the surface here where we've got these cracks that have fractured off the surface of the bricks that are there. So now we'll look at some questions. So sulfuric acid mobilizes aluminium and magnesium ions from clays in the soil water and into waterways. Explain how sulfuric acid mobilizes aluminium and magnesium ions from clays into the soil water. So the way that I would explain this is that I would say that the hydrogen ions produced when the sulfuric acid ionizes, they adhere to the negative surface of clay, and they displace the aluminium and magnesium ions that had adhered to the negative surface of the clay. And that pushes them into the soil water where they can be absorbed by plants. So the sulfuric acid produces hydrogen ions. The hydrogen ions adhere to the negative surface of the clay, and they displace the aluminium and magnesium ions from the surface of the clay into the soil water. So here's another question. It says nitrogen dioxide reacts with rainwater to form acid rain containing nitric acid. Write an equation for this reaction. So we've got nitrogen dioxide, that's reacting with water, and that forms nitric and nitrous acid. So we need to balance this. I think we need two of these. So 2 nitrogen, 2 nitrogen, 2 hydrogen, 2 hydrogens, 1, 2, 3, 4, 5 oxygens, 3, 4, 5 oxygens. So there we go, that's balanced. Second question here says, many plants do not thrive under acid conditions. Identify one effective acid rain on soil that reduces plant growth. Here I could talk about the toxic cations being mobilized by the acid rain. Last part says acid rain causes ion structures to deteriorate. Write an ionic equation for the reaction of acid rain with iron. So we're going to start with a solid ion. We're going to react that with some hydrogen ions. And we're going to make Fe2+, so ferrous ion. So acid with metal goes to salt plus hydrogen gas. So now I just need to balance it out. So I need 2 hydrogen ions here, Fes, and there we go. So the solid ion has reacted with the hydrogen ions to produce ferrous ions and hydrogen gas. So I can put in my subscript so I can see what's happening now. So today we looked at acid rain, we looked at the effect of acid rain on the environment, both natural and built, and we looked at its negative consequences. That's it for Flipping Science today. See ya.